All right, so in the world of artificial intelligence, there's this massive, high-stakes war being fought, not with killer robots, but with code. It's a really deep and expensive conflict between the two main frameworks that are building our AI future. And in this explainer, we're going to break down the absolutely ambitious quest to create a universal translator that could finally, maybe, bring peace. So in one corner, you've got PyTorch. It's the darling of the research world. It's super flexible, it's great for whipping up quick prototypes, and it's just really intuitive to use. And in the other corner, you have TensorFlow, the undisputed heavyweight champion of production. When you need to serve an AI model to millions of people without it crashing, TensorFlow is the gold standard. The thing is, they're both amazing, but they basically speak different languages. And that right there is where all the trouble starts. So why is this even a problem? I mean, who cares, right? Well, it turns out this split isn't just some nerdy debate for engineers. It has huge, real-world consequences. This division creates what's known as the two-framework problem. And trust me, it comes with a very, very high price tag for any company trying to do cool stuff with AI. Don't just take my word for it. An expert report looking into this very topic puts it really bluntly. They say the AI world is defined by a persistent and expensive fragmentation. And those two words are key. Persistent means this problem isn't just going to fix itself. And expensive? Well, that means it's literally draining time, money, and resources from businesses everywhere. Okay, so what does this mess actually look like in practice? This is the clunky, painful journey an AI model takes from an idea to a real product. So a brilliant researcher builds an amazing model in PyTorch. But to actually get it out to the world, it has to be painfully converted using some clunky middleman tool. Then a whole new team of engineers has to meticulously retest everything, just praying that nothing broke in the translation. And only then can it finally be deployed using TensorFlow. Every single one of these steps just piles on more delays, more costs, and honestly a massive headache for anyone trying to innovate. But what if you could just skip all of that? Let's talk about the solution that's being proposed. It's an incredibly ambitious project designed to bridge this exact gap. It's called the Unified AI Library, and its whole purpose is to completely change that messy workflow we just walked through. The mission here sounds almost ridiculously simple. Create a single common language, an API, that works for both. The idea is you write your code one time, and this universal API handles the rest, whether you're using PyTorch or TensorFlow under the hood. And the crucial part is that it's designed to handle everything, from the initial research all the way to the final deployment. It tackles the entire broken pipeline. And if they can pull this off, well, we basically arrive at the promised land for AI development. That MLOps friction we were just talking about, it gets minimized. Companies can streamline their entire tech infrastructure instead of having to support two totally separate ecosystems. But most importantly, it means you can get incredible cutting-edge AI out of the lab and into the real world way, way faster. So how on earth could this even work? Well, the core concept here is something called abstraction, which is really just a fancy way of saying you're building a universal translator. Instead of trying to teach TensorFlow to speak PyTorch or vice versa, you create a brand new neutral language that both of them can understand perfectly. And that neutral language has a name. It's called an intermediate representation, or an IR. You can think of it like a Rosetta Stone for AI models. The unified library takes a model, translates it into this common IR, and from there, it can be perfectly compiled into the native language of either TensorFlow or PyTorch without anything getting lost in translation. Now, I know what some of you are probably thinking. Hang on, don't we already have tools for this, like Onyx? And that is a great question. But those tools are really more like a bandage than a cure. The conversion process itself adds extra work. There's always a risk that some specific function, they call it an operator, won't translate correctly, and you often lose important info about the model. A truly unified approach, built from the ground up, avoids all of those traps. Okay, this slide really shows you just how insanely difficult this whole thing is. To make this work, you have to solve some really deep, gnarly technical problems. Like, how do you handle tensors, the fundamental building blocks of AI, when each framework deals with them differently in computer memory? How do you unify the model's internal blueprint? But you can see in that last row, the real crown jewel is a single export button that can spit out a perfectly optimized model for any device, from a giant server all the way down to your smartphone. So, an idea this big, this ambitious, it doesn't just pop out of thin air, right? It takes a very specific kind of person to even attempt it. But with that kind of ambition, come some pretty huge risks. So let's take a look at the person behind this project and some of the major vulnerabilities it's facing. The creator goes by the name KodeCharya, and according to their own profile, they don't just mess around. They actively build real applications with TensorFlow, Keras, and PyTorch. And that is exactly the rare combination of deep, cross-platform expertise you would need to even dream of pulling something like this off. It's a critical prerequisite, and it totally checks out. But here is the first huge red flag, and it's a question posed in that expert report. Can a universal translator ever be as fast and efficient as a native speaker? You see, any layer of translation or abstraction adds a tiny bit of performance overhead. The big question is, will this unified library be fast enough for real-world apps where every millisecond counts? And that leads us to the next big, scary question. It's a concept in the software world known as the bus factor. And it's a grim but effective way of asking how many people on a project need to get hit by a bus for the whole thing to just grind to a halt. Well, for this project, the analysis suggests that that number might just be 1. With potentially over 90% of the code coming from a single developer, KodeCharya, the project has an extremely high bus factor. That's a massive single point of failure, and it makes you really worry about the long-term health and maintenance of the whole thing. Okay, so let's recap. We've got a brilliant, potentially game-changing idea. We've got an architect who seems uniquely qualified to build it, but we've also got some massive, glaring risks. So what's the final call? Let's go back to that expert due diligence report for the final conclusion. The final assessment boils it all down to this. It's a classic high-risk, high-reward strategic venture. The risks of performance and that single-person dependency are very, very real. But the timing? The timing couldn't be better because it aligns perfectly with one of the biggest trends in all of technology today, the massive shift to edge computing. And this chart here shows you exactly why that timing is so good. There is a huge push for edge computing. That's running AI directly on your phone, in your car, on your smart speaker, not on some faraway cloud server. This gives you instant results and it keeps your personal data private. So a library that makes deploying AI to hundreds of different types of devices simple, that's not just a nice to have. That is the holy grail everyone is looking for right now. So it's not hopeless. The report actually gives a pretty clear roadmap to success. First, prove it's fast. Release public benchmarks that show it's almost as fast as using the native frameworks. Second, build a real team around it. Formalize the project, improve the documentation, and lower that bus factor. And third, absolutely nail the export to mobile-friendly formats like TensorFlow Lite. That is the killer feature. That's how you win. And all of this leaves us with the big billion-dollar question for the entire industry. Is this project a glimpse into the future? Are unified libraries going to become the new standard for how we all build AI? Or is the fragmentation just too deep, the technical hurdles too high, leaving the AI world, well, forever divided? The answer to that is going to shape the next decade of technology.